Hey guys, welcome to another video. So today we're looking at ionic equations. Alright, so before we get into ionic equation, I just want to thank you guys for subscribing and sharing and liking the videos. Right, so we've just reached 100 subscribers, right, and it's all because of your help. So I hope that these videos will actually continue to grow so other persons can learn about chemistry as well as physics. Alright, so thank you very much guys for watching, and ensure that you tell others about it so they can learn as well as to understand physics and chemistry. Alright, so let's get into ionic equations. Alright, so ionic equations show us the active ions that are present within an ionic compound during a chemical reaction. Alright, and what I mean is that these are the ions that combine to give you these ions, right? So that's what the ionic equation tells us, right? So previous lessons, we have actually introduced you guys to the state symbols for chemical equations, that S represents our solid, L or liquids, aqueous mean AQ, right? And aqueous means that the compound is able to be dissolved in water, right? And then G is for gas, right? So before we get to doing our ionic equations, we have to know this right here, right? So need to know, very important. So we know that all salts of group 1 elements and of ammonia are soluble. So once you have a group 1 element bonding with a non-metal, right, to give you a salt, all those compounds would be soluble, meaning that our state symbol would be aqueous, right? And then we know all nitrates and acetates salts are also soluble, right? So those are two important things. All halogens of salts, right? So once it ends with a halogen, and remember halogens are group 17 elements like chlorine, fluorine, right? So those are soluble except when they're combined with silver, mercury, or lead too, all right? And then we know all sulfates are soluble except when they are combined with strontium, barium, mercury, or lead. And we know that hydroxide and sulfides are soluble except with group 2 elements and with ammonia, right? And then carbonate and phosphates are soluble only with group 1 and ammonia compounds. All right, so we're going to actually see how much of these rules we need to actually get our problems solved here with ionic equations, right? So to do ionic equations, we will have our normal chemical equations, right? And what we're going to do to make it be ionic is that we're going to split all our aqueous solutions or aqueous compounds into their ionic forms, right? So the important part here is we're only going to split the aqueous compounds, right, to their ionic forms, and then we cancel the common ions from our products and our reactants only. All right, so let's look at this one here. So in this case, we have sulfuric acid mixing with barium nitrate to give barium sulfate and nitric acid or hydrogen nitrate, right? So the first thing here, we notice we don't have any state symbols, so we need to introduce our state symbols, right? So we know that all acids, right, are soluble, and we can check that because it's a sulfate. So if we look at sulfates here, we say all are soluble except, and we notice hydrogen is not there. So that means if it's soluble, then that means the symbol here is AQ. All right, and then we look to barium nitrate. So we look for nitrate, right? So all nitrates are soluble, right? So that means barium nitrate is also aqueous. Then we go to barium sulfate. So we go sulfates here. They are all soluble except, and we notice barium sulfate is an exception. So that means it will create a precipitate, which is a solid, right? So it's not soluble, so that's when you mix something and you see the residue at the bottom, right? So barium sulfate would be that residue in that reaction, so it's a solid. And then hydrogen nitrate or nitric acid there is also aqueous. That's because all nitrates are soluble, right? So we have our state symbols, right? So that's the first thing. Next is to ensure that equation is balanced, right? So in balancing this, we put a 2 here to balance the H's, right? So we have 2H, 2H there, 2NO3, 2NO3, 1 barium, 1 sulfate, right? So that's balanced there. Now the next thing now is this part. We're going to split all our aqueous compounds, right? So in splitting our aqueous compound, let's hope we can have that space there, right? So we split H2 plus, so that is 2 plus SO4, 2 minus, right? So we split that, right? So we still keep our symbols there, sorry, plus barium is also, so we split barium and nitrate, right? And that gives us barium sulfate. It's a solid, so we don't split if it's not aqueous. Plus, we have 2H plus aqueous and 2NO3 aqueous, right? So we have that. So now we can go ahead and cancel our common, right? So we notice we have any and any, H and H right there. So we can cancel that, right? We have NO3 here. We can cancel that as well, right? So, and sorry, this is 2, because it's 2 there, right? And also, this is 2NO2 right there, right? So we get those canceled. So the only thing that remain in our reactant would be Ba and SO4, right? So you can write it this way or barium first, it doesn't matter, right? So the final output would be, it's barium, sorry, that's not right then. So it's barium 2 plus, and we remember state symbols, plus SO4, 2 minus, equals, to give, the only product here is our barium sulfate, and that is solid, right? So this is our reaction between, this is our ionic equation for this chemical reaction, right? So the ones that, so these are called our spectator ions, right? So that's, these two ions would be the active ones to be bonded to give barium sulfate. All right, so that's it for the first one here, and let's do the second one. All right, so now that we know how to do it, we can go a little faster. All right, so copper chloride, so symbol, so chloride is a halogen, so all halogens are soluble except for these, which is not copper, so we put our aqueous here, right? And it's mixed with zinc. Zinc is actually a metal, right? So because it's a metal, it's in its solid state, right? And then we get zinc chloride, it's also not an exception, so it's aqueous, and then it gives us copper, which is a solid, so it is S, right? So in this case, we ensure that we balance the equation. So it's 2 chloride here, we put 2 there, makes it 2 copper, so we put 2 right there, right? And that's balanced, right? So now we go ahead and split our aqueous compounds, right? So we have 2 copper, right, aqueous, which is 2 plus, which is a plus here because it's just 1 copper plus here, plus chlorine, which is aqueous, and it's 2 chlorine as well, right? Plus zinc, which is solid, to give Zn, aqueous, 2 plus, plus chlorine, negative, aqueous, it's 2 chlorine, right, plus 2 copper solid, right? So now we can cancel out our common, right? So we have 2 chlorine here, aqueous, cancel 2 chlorine aqueous there, nothing else is common, so we are left back with this 2 plus the zinc to give Zn2 plus equals plus 2Cus. Right? So this would be our ionic equation, right, for that chemical reaction. Now let's look at the second one, right? Because the second one is kind of nice, right? So let's go. So we have a carbonate, which all carbonates are soluble except all soluble with group 1 and ammonia. So sodium is group 1, so it is aqueous, right? Potassium nitrates, we know that all nitrates are soluble, right? So that's aqueous. We have hydrogen carbonate, which is group 1 is soluble, and hydrogen is in group 1, so that's aqueous. And then sodium nitrate, we know, is soluble, all right? And ensure we balance, so we have 2 Na here, so we put 2 Na here, makes it 2 NO3. We put 2 here, and please note this is a K right here. All right, so we balance everything there now. All right, now we notice here that each thing in our equation, so each ionic compound here creates, it's an aqueous solution. And what that means is that there is no chemical reaction. Because if we cancel out, if we break up all our aqueous here, we're going to cancel out each from each side. So in this case, because no ion is present, we have no reaction. All right, so that's how we can actually state if we know a reaction will occur with ionic compounds. In all cases, if there is all aqueous, then there is no active ions to take part in the reaction, so therefore it is a no reaction. All right, and let's look at the last one. So we go sodium carbonate. Carbonates are soluble from group 1, so sodium is in group 1, so it's an aqueous. Hydrogen chloride or hydrochloric acid, it's aqueous, hydrochloric acid, sorry. And then sodium chloride, all chlorides are soluble, sorry, so that's an aqueous. All right, then we have water. Water is in its liquid state here. And the reason why we know water is liquid and not gas is because it's not a reaction that is going to be heated, right? So this reaction is not heated, so therefore the water that's produced is liquid. And if it was heated, then we'll actually use a gas. All right, and then we get carbon dioxide, which is natural state, is a gas. All right, so again, we ensure that we balance our chemical equation. So we have 2 Na here, so we put 2 here. So we have 2 Cl here, so we put 2 here, 2 H's, 2 H's. We have 3 O's and 3 O's there. All right, so we have our chemical equation balanced. So now we can split up our aqueous. So we have the Na, so it's 2 Na. All right, so let's use some space over here. So we have 2 Na plus, remember sign, aqueous, plus copper plus carbonate, which is aqueous, plus 2H plus aqueous, plus 2Cl negative aqueous, to give 2Na plus aqueous, plus 2Cl negative aqueous. All right, and we have those 2 here, which are liquid, so we have no splitting of those compounds. All right, so now that we have our full broken up equation, we can cancel the common. So we have Na here, Na here. All right, we have 2Cl here and here. There's no more ions on that side, so we don't need to look on this side either. So the final output would be these 2 on this side. All right, so we have CO3 2 minus aqueous plus 2H plus aqueous to give, and we're given water, which is in its liquid, and carbon dioxide in its gas state. All right, so don't need to worry about balancing the ionic equations, right? Because we already balanced the initial equation, so when we get our ionic equation, it's also going to be balanced as well. All right, so that's how we get our ionic equations from any chemical equations with ionic compounds. All right, so remember, ionic equations only work for ionic compounds. All right, so thank you guys for watching today, and hope you understand something about ionic equation. Ensure to share this video and tell your friends about it. All right, and see you guys next time.